Hi everyone! In this video we will graph a linear inequality. Graph the linear inequality y is greater than negative 3x minus 1. The first thing we need to find is the y-intercept and the slope so that we can graph this boundary line for the inequality. The y-intercept is the second portion without the x, so it's negative 1, and the slope is the number in front of the x, which is negative 3. So we can go over to our graph and go down negative 1 for the y-intercept. And from this point, we need to move as a rise over run of negative 3. We can put it over a 1 because negative 3 divided by 1, it keeps its value of negative 3, and that gives us a rise over a run. So from this point, our y-intercept, we will go down 3 because we rise, negative 3 goes down, and run in the positive direction 1 to the right, and that's another point for our line. We could do it again as well. So from this point, we could go down 3 again, 1, 2, 3, rising downwards, and then running in the positive direction, which is to the right, 1. We could also reverse those and do 3 over negative 1, because positive 3 divided by negative 1 is negative 3 still. So we can rise positive 3 units, 1, 2, 3, and run backwards left 1 unit in this direction. Now we have a bunch of different points that are all in the same line, the boundary line, for this inequality. Now we need to connect them, but we need to know how to connect them. So let's look at the inequality. We have a greater than sign. If we have greater than or lesser than, then we have a dashed boundary line. If we have a greater than or equal to or lesser than or equal to, we will have a solid boundary line. Because ours is just greater than, it's going to be a dashed boundary line. Now I need to line these up with a straight edge as accurately as possible, making a dashed boundary line through those points. And then we cap it off with arrows that indicate that it will continue going on forever because the line will continue. Now we just need to know which direction we should shade. Because this is a y is greater than, this means that I will shade above the line. And this method works if the equation or the inequality is in slope-intercept form, because then I'm looking at the y on the left. And because it is greater than, then it goes above. If this is something that's unclear or you just want to verify, then we can pick some test points to know which direction to shade. I'm going to go ahead and pick this point here, which is not inside of the portion, the shaded portion that I've picked. This is the point. We've gone to the left 2 and we've gone nowhere up and down, so it's negative 2, 0, and see if it is a solution to this inequality. If it is, it should be in the shaded portion. If it's not, then it is not in the shaded portion. So let's go ahead and substitute that in. 0 for y and negative 2 for x, so negative 3 times negative 2 minus 1. Negative 3 times negative 2 is positive 6. 6 minus 1 is 5. And then we ask ourselves if it made that inequality true. Is 0 greater than 5? It is not. So the point negative 2, 0 is not a solution and should not be shaded. So let's try another one. Let's try over here with positive 2, 0. And this is showing in my graph that it is in the shaded region, so we do want it to make the inequality true. So we'll substitute that in. 0 is greater than negative 3 times positive 2 minus 1. Negative 3 times positive 2 is negative 6. Minus 1 is negative 7. And we ask ourselves, is 0 greater than negative 7? And it is, which means it is a part of the solution set and should be in the shaded portion, which it is. So we have shaded in the correct direction of our inequality of the boundary line, and we're all done.